Hi guys! Today we're going to talk about Sir Isaac Newton. Sir Isaac Newton is super old school. He's from the 1600s. He was born in 1643, so this is before the Industrial Revolution. And what's awesome about Sir Isaac Newton is that not only is he a super science nerd, but he's also a super math nerd. So he looked at the natural world around him and basically applied mathematical reasoning and mathematical concepts to these patterns that he saw around him. So this picture here, I really like it because it shows a lot of what he studied. He was very eclectic, meaning he liked a lot of things. You can see in the upper corner that he studied gravity, and it shows the orbits of the planets around the sun. So he studied the heavens through this beautiful telescope that's in the foreground. He studied the nature of light, so the light coming into the prism and getting refracted into the rainbow there right in front of him. He wrote this book on the mathematical principles of nature. And then to the right, you can see there's a moon in the background and there's an ocean. So he studied the tides, and he was the one that linked the patterns of the moon and sun, the gravitational pull of the moon and sun, to how much of a tide there is along a coastline. So the ocean actually swells up and then draws back from the land twice every day, and he linked this to the fact that the earth is spinning, and as it's spinning, the pull of the sun and the moon actually tug on the water on our planet. And then finally, in the upper portion of this screen, we've got an apple falling from the tree, and the story goes he was out in an orchard, saw an apple fall from a branch, fall to the ground, and he realized that there must be a force that was pulling everything down. And so he came up with the idea of gravity. So he came up with 3 laws, and the first law is really about whether or not there's going to be a change in the motion of an object. So will a still object start moving? Will a moving object slow down and stop? Or will an object change its direction? So obviously, based on these 2 pictures, some things are going to be easier to stop than others. It's going to require more force to stop a tractor-trailer truck than it will take to stop a little toddler on a tricycle. I'm not willing to stand in front of a truck and say, you can't drive here, but I am willing to stand in front of the toddler and say, you can't ride out into the road. Some things, on the flip side, are going to be harder to get moving than others. So the large appliances over on your left, those are going to be harder if you wanted to try to apply a force to move them. It's going to be harder to move those than the little kid playset over on the right. So both of these, to get them to move, you would need an unbalanced force. You need to push hard enough. But because there's more mass, it's going to take more force to move the kitchen set on the left versus the kitchen set on the right. So basically, Newton's first law of motion states that an object won't change what it's doing. It will not have a change in its motion unless it's acted on by an unbalanced force. So the way they like to say this is, if an object is at rest, it will stay at rest. And if an object is in motion, it will remain in motion until we have this unbalanced force added to it. And down below, it actually uses this fancy word, inertia. So with mass comes this property called inertia. You do not need to know that word, but if somebody throws it out at you, that's what it refers to, just how much mass an object has. So it's going to be harder, take more force to overcome the inertia of the 300 kilogram ball versus the amount of force it would take to overcome the inertia of a 30 kilogram ball. So if you can go ahead and get out your notebooks right now, we're going to go ahead and take some notes on Newton's first law of motion. So Newton's first law of motion says that, and I'm going to paraphrase here, an object will keep doing what it is doing until an unbalanced force is applied. So, if something's moving, it's going to keep moving, and if something is sitting still, it's going to keep sitting still until the forces on that object are unbalanced, and then it's going to move in the direction of that force. So, let's go ahead and draw an object that is at rest. And I'm going to go ahead and I'm going to draw a chair. Oh, I hope I can do this. And that chair does have forces applied to it, but right now they're balanced, right? So gravity's pulling down with, I'm going to say, 15 newtons. But because the chair is sitting still at rest, we have 15 newtons pushing right back up. Until along comes, you know, a very helpful child of mine that wants to help me cook dinner, and he still can't reach the stove, right? So he is going to come along. Oh, don't worry, my children don't have heads that look like that. And he is going to push the chair. And once he pushes the chair with, I am totally making up this number, 20 newtons to the right, now the chair will start to move. And because the unbalanced force is from the left moving to the right, the chair will start to move to the right. Moves right. Whew. I'm not actually writing on my board right now. I'm trying to do this. I don't know if you can hear the clicky mouse. There we go. Okay. Now, an object in motion, just in motion. An object in motion is actually going to stay in motion. So do you remember we had that Mars lander, the InSight lander that landed just this fall. So here's Mars. Everything has to come back to Mars, guys. I'm sorry. So we've got Mars here, this lonely little planet, nothing alive. And we've got the atmosphere, right? Here's my attempt at a dotted line. And remember, that atmosphere is pretty thin, but all it takes is enough collisions with individual air molecules, and we have our disk coming in. It was cone-shaped, roughly. NASA loves making this shape. And it was coming in super, super fast. The entire time it was traveling from Earth, it was coming in at 6,200 miles per hour. And once it reached that speed in outer space, it just stayed at that speed. There was nothing in its way to apply a force, and so it traveled for millions of miles at that speed, roughly, give or take, because it had nothing, there was no unbalanced force applied. It's going to stay there until these little air molecules get in the way. And the air molecules, there's my dog. The UPS man must be here. So, the air molecules are going to apply a force, a friction force, and slow it down. Friction slows down everything. Friction. Also called air resistance. And there you go. Newton's first law. An object at rest is going to stay at rest. An object in motion is going to stay in motion until an unbalanced force is applied, and it's going to change the motion in one way or another. Thanks so much, guys.